the scary technique used by U.S. Air Force to start up stealth F-22s. The ground shakes, smoke explodes, lights flash, and from the chaos, the F-22 Raptor rises, invisible to radar, unstoppable in the air, and today we'll reveal the scary secret behind its startup. The history of that fearsome startup dates much earlier than the F-22 Raptor happened to live. The United States was challenged seriously during the peak of the Cold War. The Soviet Union was developing more advanced radar systems and surface-to-air missile systems, which would spot and shoot down conventional aircraft long before it could even hit its targets. To go flying at one of those defenses by conventional fighters would be to suffer unacceptable casualties. To beat this, American engineers considered an extreme concept, which was aircrafts that could hardly be detected by enemy radars. These were pioneer stealth efforts, which provided the background of current stealth technology necessary to revolutionize aerial warfare. The F-117 Nighthawk, which was launched in the early 1980s, was the first operational stealth aircraft. Although given the fighter-like designation, the F-117 was actually a precision strike aircraft that was developed to penetrate the hugely defended airspace during the night hours. Its sharp form and radar-absorbent coatings drastically dropped its radar cross-section, enabling it to maneuver enemy defenses almost invisible. The development of stealth technology persisted until the release of the F-22 Raptor, a fifth-generation air superiority fighter whose destined role was to conquer contested airspace. The Raptor adheres to the first look, first shot, first kill philosophy, unlike its predecessors who were concerned with dogfighting. In simple terms, it identifies enemies in advance, shoots first, and destroys threats before the opponents have even noticed that there is a threat nearby. At the core of this capability, there are two Pratt & Whitney F119 engines, which allow supercruise or sustained flight at Mach 1 or above without afterburners. This provides the F-22 with an incredible speed, range, and fuel efficiency. The design of the Raptor focuses on stealth with curvilinear lines, angled planes, and internal weapons bays, which are all covered with radar-absorbent substances. Even its weapons are not revealed in the fuselage until they are deployed, reducing the radar signature. Advanced sensor fusion takes radar, electronic support, and offboard data to a single clear tactical display in cockpit. This enables the pilot to have situational awareness without being bombarded by multiple systems. Designed to take advantage in air-to-air fighting, the F-22 has limited precision strike capability. Its fragile stealth fields and systems cost a lot to maintain, yet the operational reward is unrivaled air supremacy. Then there is the part that leaves viewers in a state of shock, the startup sequence. An F-22 has an auxiliary power unit, APU, that is activated when an F-22 is started. This is a small internal engine that supplies electricity and pressurized air to commence main engines. As the APU rotates the exhaust gases and pressurized air is released through vents on the fuselage, creating massive clouds of smoke, which can appear threatening to anyone unfamiliar with the process. This is quite normal to the trained crew, though. Pilot and crew chief conduct thorough pre-flight inspections, which include checking landing gear, control surfaces, and outer systems during startup. It is after such checks are made that the F-22 taxi is made to the runway. When it is in the air, the real power of the Raptor can be seen. Thrust vectoring nozzles enable the engines to blow either slightly high or low to give the plane extreme agility. Together with sophisticated flight control computers, the F-22 is capable of performing post-stall maneuvers and remains in control at angles that would drive most fighters out of the sky. This enables pilots to sustain steady level flight at extremely high angles of attack, outmaneuver other pilots, and reposition in short order to take on missile attacks. The engines of the Raptor also give the aircraft an outstanding vertical climb capability and transform altitude and energy into tactical edge. Air combat is not only about single-plane operations, but it also depends on a huge logistics and support system. A major one is the Forward Arming and Refueling Point, FARP, which is a temporary forward base where fighters are able to quickly refuel and rearm and get back into battle. Aircraft decrease the time spent on transit and enhance the speed of operation by working nearer to the front lines. FARPs use fuel bladders, pump units, hoses, and filtration systems to provide fuel to aircrafts in a safe manner. Their designs focus on speed of access and exit zones, reducing time on the ground and rendering such aircraft as the F-35 Lightning II difficult targets. F-35 is another fifth-generation stealth fighter, which combines stealth, sensors, and precise strike in a single platform. Its internal weapons bays preserve low radar observability. Loading weapons requires precision, Ground crews use hoists, alignment tools, and digital checklists to mount missiles and bombs on trapeze-style launchers, which extend briefly into the airstream during deployment. Though slower than external pylons, this approach significantly increases survivability and maintains stealth during critical combat phases. The F-35B model has short takeoff and vertical landing, STOVL, with the help of a lift fan. This permits operations by shorter runways or amphibious vessels. The use of these advanced aircraft requires training to utilize them fully. F-16. Fighting Falcon pilots have live-fire bomb run drills that occur over specific ranges and against hardened and simulated targets. These missions introduce pilots to various attack profiles, diving, tossing bombs, and low-level strikes, educating them on how altitude, speed, and approach angle impact on the bomb trajectory and precision of strike. Futuristic target pods offer real-time identification and tracking, which are analogous to combat conditions. Other than fighters, military aviation also comprises heavy-lift support planes such as the CH-53E Super Stallion, which can carry 36,000 pounds of cargo, such as vehicles, artillery, or 55 troops. The Super Stallion is equipped with 3 General Electric T-64-GE-416/419 turboshaft engines that enable it to deliver equipment to faraway places and even fuel mobile vehicles. Its long refueling probe greatly increases its range of operation, and its tail rotor is mounted high so that it can be loaded easily and quickly through the rear ramp. The naval logistics is equally important. Cargo transport across oceans is accomplished by ships such as the USNSC TAKR-302, which is a Watson-class large medium-speed roll-on/roll-off LMSR cargo ship, tanks, helicopters, trucks, and gear. The sea has more than 380,000 square feet of cargo capacity, which allows it to be used in prepositioning and surge sea lift, allowing it to be deployed anywhere in the world very quickly. During high-tempo missions, heavy equipment is loaded initially so that it will be stowed in a balanced way, and work is done 24/7. Air Force is stretched by strategic bombers such as B-52 Stratofortress, B-1B Lancer, and B-2 Spirit. B-1B can fly at supersonic speed, and B-2 is the only stealth strategic bomber in service in the world. The capabilities of each aircraft are different, with variable sweep wings to control the plane and stealth penetration to counter the nuclear deterrence efforts. New technologies continue to push the envelope. Raytheon's high-energy laser weapon system, HELS, is a directed energy weapon designed to neutralize drones, mortars, and other small projectiles almost instantly. Using a 10-kilowatt solid-state laser with advanced electro-optical and infrared sensors, HELS delivers silent, precise, low-cost engagement without traditional ammunition. Mounted on vehicles or shipping containers, it can operate in forward-deployed environments and integrate with existing radar and command systems for network-based defense. Yet, despite all these technological marvels, the most captivating moment remains that dramatic startup on the runway. The F-22 Raptor, powered up and exhaling thick clouds of smoke, represents the combination of engineering excellence, stealth innovation, and tactical supremacy. To outsiders, it may look frightening. To the crews and pilots, it's the prelude to another mission for one of the world's most advanced fighter aircraft. If you find this video interesting, then don't forget to like, share, subscribe, and comment for more fascinating military technologies. See you in next video.